All right, I'm Brandon. We're going to talk about analyzing a malware sample in VirusTotal. So this is a super low effort talk. The entire purpose of it is to demonstrate that you too, with almost zero funding or budget, can do stuff like this for your own organization or just for your own purposes at home. So there's nothing special. I don't have any special access into this. We're just going to look at some stuff together, and we're going to analyze a malware. There's a couple of things that I want you to keep in mind as we go through this, which I will talk about here in a little bit. But first, a little bit about me. I'm Brandon Gilbert. I am a mediocre race car driver and a mediocre golfer. I worked at a bunch of places. I currently work for Mandiant. Actually, I think today or yesterday was my 3-year anniversary. I think that's the longest I've worked for like anywhere. Kind of big deal, so pretty stoked about that. This is my family. I have a dog, Charlotte. I have 2 cats. They are disgusting creatures that poop inside. I have my wife right down there in the lower right-hand corner. I hope you can see her. She's also right here with us. Everybody say hi, Zina. Thank you. That embarrassed her and made me happy. So things that I want you to keep in mind for this talk. This is a graph representing my understanding versus attack complexity versus the misplaced confidence in me providing this talk at all. So where I can look at simple VirusTotal by certain level of things, what we're not going to do is reverse engineering. We're not going to look at binaries. We're not diving into Ghidra. I'm not that smart. Some people here are that smart. Great for them. That's why I love SecDSM. I'm not that person. And I think most of you probably aren't. I think most of us probably aren't. So we're not there yet. Another thing I want you to keep in mind is I got really invested in how to do PowerPoint or slide animations. So check this shit out. We're going to be talking about detection engineering opportunities. So whenever you find a detection engineering, this keeps going. Whenever you find a detection engineering opportunity, this is the audience participation portion, which is always really hard. I want you to say something, raise your hand. I want you to scream detection engineering. I mean, nobody's actually going to do that, but we're looking for detection engineering opportunities here at the end of the day. So if you see one, I want you to say something. Otherwise, I'm probably going to give you some clues that maybe there's a detection, or you already see a detection engineering opportunity. Yes. All right. So that's pretty much it for slides. So that's cool. Oh, wait. I have one more slide. Go to demo. Yeah, we're going to go to demo now. Let's start in VirusTotal. All right, so is that big enough? Make it bigger. Oh, that's too big. There we go. We're in VirusTotal. You got sent a hash. Let's say that you got sent, I don't care how you got sent this hash. You got sent a hash, and now you need to go look at it. So what we are in is VirusTotal. This is the premium version of VirusTotal, so you're going to get a little bit more insight. But I think that for a single person, the premium version of VirusTotal is fairly cheap. I'm not a salesman for VirusTotal. I don't know. But this is the premier version, the premium version. So when you search a hash, the first thing it's going to do is take you to this details page. It's going to have some details in here. We know that this file is an LNK file. It's a shortcut. It's a Windows shortcut. I'm going to adjust this down so I can look at my screen and talk to you at the same time. So this is a Windows shortcut file. It's an LNK file. We have a creation date. We have a bunch of other metadata in there. We have a name of the file. I'm going to copy this out just to use it a little bit later. We have some network infrastructure. So at some point, it has something to do with this helper.exe. We don't really know that yet, how it's associated. And then down here we have a whole bunch of other information. I'm going to stream through most of this, but hey, this looks kind of interesting. We have a command. What? Engineering opportunity? We're literally just analyzing the file. I think you're close. I think you might be onto something. So I guess to start off, for anybody that doesn't know what an LNK file is, it's just a Windows file with the .lnk extension. It just points to something else. It's just a pointer. So when you double click it, when you execute it, it just goes and does an instruction set. In this case, we have a command line argument that is C, echo, and then a whole bunch of gibberish. We don't really know what that is yet, but maybe we can figure that out. We have a relative path in here. Oh, I mis-highlighted. We have a relative path in here of a bunch of dots and slashes in cmd.exe. Does anybody know what the hell that is? Oh, directory traversal, I heard that. Okay, so it's setting a relative path of going back, going back, going back, going back, going back as far as it can, and then looking for Windows System 32 CMD. So it really wants to launch CMD, but before it does that, it's going all the way back because it doesn't know the context in which it's launching in, right? So it's called a directory traversal attack. You know what we also call this? A detection engineering opportunity. Okay, but we're also not there yet. We're just still analyzing the file. So a bunch of there's an icon address in here, there's a MAC address, there's a bunch of other information here, but I'm kind of sick of looking at this. I have ADHD, I can't look at that long. Actually, I'm going to just jump straight to content because that sounds like the most interesting. So when you click the content button in VirusTotal, which is a VirusTotal premium feature, sorry pores, it pretty much just runs strings on the file. Strings, however, is just a free feature. So if you can download the file and you can run strings on it, VirusTotal just kind of does this for you. So we're looking for strings within this document or within this file. And we can see a couple of the strings that we already know. We know this is the icon file, right? We just found this. We know, here, there's that weird directory traversal thing that we talked about, the relative path, and then we have this big blob of text here. Oh, I highlighted too much. We have, unclick it. We have this big, oh no, that is the whole path. We have this big blob of text here, which probably is our command line arguments. So some of you might be thinking, what the hell is this? Close, but wrong again. It's base 64. We're going to go to talk links, and we're going to go to cyber chef. Let's see what the hell. Well, actually, I'm getting ahead of myself. Sorry. So we know that it's doing a /c echo. So if it's launching CMD, /c would be we're passing a command. Echo is we're just echoing data. We're echoing data into a file called hwmk yada yada .bat. And then we're doing some other stuff. But all that's really confusing right now, so we're just going to stop there. So let's see what this base 64 is. We're echoing some base 64 into a batch file. Our trusty friend CyberChef, also free. Think England? England made CyberChef free? Thank you, England. Apparently. Today I learned. So, okay, we're going to base 64 this. And we see some other weird stuff going on. Start min PowerShell command IWR. That's an invoke web request to some website.php. And then we're writing that file to a JavaScript. We're deleting a scheduled task. That doesn't make any sense. And then we're using WScript to launch the JavaScript. That doesn't make any sense right now. We're going to get there together. Shut up. I'm getting there. All right. So what does it do after it writes the base 64 to the file? It runs certutil to decode that file, and then it puts the output file into the batch file. So it's writing the code that we just saw into a batch file, and then decoding it with certutil, and then just writing it to that batch, the same exact batch file. Detection engineering opportunity. Okay, okay, sorry, we'll get there. We're just analyzing the file so far. And then we create a scheduled task to execute a scheduled task every 1 minute. That's the task name right here. Oh, I can't highlight it. To execute the batch file once a minute. And then that's it. That's pretty much it for the command line arguments. So let's go back to that CyberChef thing. If the scheduled task gets successfully executed, make it bigger. Whoop. So if that scheduled task gets successfully executed, right, the batch file, or the initial command, the LNK file, is creating the scheduled task to execute the batch file. If the batch file gets executed, we're going to launch PowerShell to do this download of this JS, and then we're going to delete the scheduled task. Does anybody have an idea why we would create the scheduled task and delete the scheduled task? What? That's actually one good reason. It could just be so you can't trace it. But also, it's so the scheduled task doesn't just keep running and keep downloading this file, right? So if the batch file is successful in executing, then it's going to have download the second stage, which then it doesn't need that scheduled task anymore. So then the second stage contains the function to remove that. So that's really interesting. And then we leverage WScript to invoke the JS. So let's take a high-level view. We're going back to our slides. So here's where we're at. Oh wait, can I make this big? Slideshow. All right. This is the most amount of effort I put into this entire presentation, was creating this. So our initial access vector doesn't really matter here because we're already past that, right? We already have the file. We already have the hash. We already know something. But our initial access vector could have been a spear phishing attachment, could have been a drive-by compromise. Either way, this LNK file got onto a system somehow. When the LNK file executes, it drops the batch file, leverages a scheduled task to execute that batch file, and then that batch file gets decoded by cert util, which executes a PowerShell script, which downloads and executes a JS file. So that's all we know about the LNK file so far. Is everybody with me? All right, everybody says that they're with me. I'm going to take a drink real quick, and I'm going to let you digest all that. Thank you, Zaina, for bringing me that drink. Everybody say hi to Zaina again. It makes her uncomfortable. Thank you. All right. I think we're done with this file. So at this point, we understand that the later stage of the LNK is to execute the JS. But I don't really want to jump into the JS real quick, or quite yet. I mean, I do have it pulled up, but I don't really want to jump into it yet. My first question is, already we've found a handful of detection engineering opportunities, but how do you know that your AV provider, how do you know your CrowdStrike or your MDE or your SentinelOne doesn't already detect this behavior? This is where we get into the fun job of security validation. That is my full-time job, is security validation, and that's why I can kind of do some of this stuff. But when you at work, you say, we don't have a budget for security validation. How can we do security validation at my company? You need a VM and VirusTotal. We can validate this together, and that's what we're going to do. But it's a live demo, so it's going to be really, there's a chance that this might not work. So what do we know? An LNK got dropped. New shortcut that creates an LNK. The first thing I kind of want to try is, what's the first thing that the LNK did? It dropped it just opened up command prompt, right? C:/Windows system32/cmd.exe. Next. We'll call this malicious.lnk because it's malicious. All right, so we have an LNK file now that launches CMD. I'm just going to double click it. Command prompt shows up. Who am I? It's definitely a command prompt. Can we really write a detection on that? I mean, maybe. Does anything else? Does LNK ever spawn CMD? Believe it or not, sometimes it does. So if I look at CMD and I open up file location, please do it for me. Right there. Programs. This right here is an LNK launching CMD. So we can't really write a detection directly on that. But what other situations is an LNK launching CMD that isn't maybe from this directory? Is that maybe a detection engineering opportunity? Is there any other reason for an LNK to spawn CMD? Probably not, but part of the brilliance of detection engineers is to go find situations that fit outside of that norm and then write detections for when that norm doesn't happen. Is anything malicious happening with an LNK launching CMD? Not inherently, but it could be an indicator. So we kind of have like a step one. But that's not all the malware did. We can't just launch an CMD with LNK. So the next thing that we need to do is let's make this look a little bit more like what the malware looks like. So we know that it started in temp. Oh, temp. This probably isn't big enough. No, I don't know how to make it any bigger. Well, okay, so I'm changing the start in directory to temp because that's what the malicious file did. And then I also created this file over here. I'm going to make this big that has all the commands that I need to just copy and paste in here to make this work. So that way I don't have to do it quite as difficult. So let's just try and launch CMD via a LNK file and run an arbitrary command. In this case, I'm just going to run oh, that's not the big one. I'm just going to run a who am I and write it into a text file. I'm just running an arbitrary command. I'm not doing anything special. You probably saw what's coming next. All right, so I'm just going to paste that in there. I'm going to hit apply. I'm going to double click this LNK file. Oh, where the hell did it go? Let's go look in our temp directory because that's where we set the path for. It's a bunch of junk. Oh, there's a mal test in here. Malware man. That's me. I'm the malware man. So we know that that command executed correctly. And I don't know if you guys have noticed, but MDE hasn't popped up and said anything malicious happened. That's concerning. So maybe that's not super malicious. But what if we do the same thing that the LNK did? What if we write base64 encoded command into a batch file, and then we use cirtutil to decode it, and then we execute the batch file? When does that happen in an enterprise environment? Like, that's weird, right? Is that maybe a detection engineering opportunity? No. Yeah, no, you double base64 your patches, so you never have to worry about that. As long as you keep base64 encoding it, they'll never find you. Yeah, we found that out. The limit is about 72 times. All right, so we're going to go into this file. We're going to modify this yet again. Sorry, I can't make this bigger, but trust. What we're doing here is we're literally just going to make this. I'm going to go back to this page because this was bigger. We're doing the same exact thing here. We're passing a /c. We're echoing a bunch of base64 into a batch file. We're going to use cirtutil to decode the batch file. Then we're not going to do the scheduled task stuff. Ain't nobody got time for that. But then we're just going to execute the batch file and see what happens. But before we do that, I need to go back into this folder. We need to delete the mal test. We already validated that first command can run. So that's what this command is doing. We're going to cmd echo a bunch of base64. We're going to use cirtutil, yada, yada. I already explained it. I don't know why I'm explaining it again. Let's double click it. Wait, did I double click it? Do it again. Oh, we got the pop-up. What do we have in here now? We have, can I make this bigger? Oh, it's trying. Okay, we can see a mal test, like a batch file here. And then we can see a mal test doc here. We're going to open this. That to me tells me that the code executed successfully without any sort of intervention from MDE. MDE didn't do anything. But to be fair, nothing malicious really happened, right? So why would MDE do anything? But it's still a detection engineering opportunity, because if this kind of behavior happens, could be malicious, I bet your SOC wants to know when this sort of behavior happens. All right, what's next? So we validated kind of the behavior of, oh, I clicked the wrong thing. We kind of validated the behavior of this LNK, but we haven't actually tried to launch the LNK, right? All this in here, if I click on this detection tab, it says that it's malicious, right? Oh man, all this is so bad. But why didn't it detect it when we did the same exact thing? What's the difference? There really is no difference. The only difference is all of our vendors have a signature for this one, but we don't have a signature for the one that I just created, even though it's doing the exact same thing. That's the importance of detection engineering, proactive versus reactive. Does that make sense? Hopefully that makes sense. Fuck it. Let's just try and run it. Is that a bad idea? Does anybody think that's a bad idea to just run it? I'm getting some indications that maybe I should just do it. All right, we're gonna extract this. What is this? What's in here? Oh, I already extracted it. We're gonna extract all. We're gonna extract this. What do y'all think the password is? I heard too many things, but I definitely heard the password correct once. It's just infected. Oh, fuck! Oh, it did not like that at all. It did not like that at all. All right, well, let's look at the properties of this file. What makes this file different or better than my file? Oh, shit. Oh, God, MDs. Oh, it got rid of it. It deleted it. Fuck. Okay, well, okay, so we can't run this file. So does anybody have any ideas what we should do next? You all think I should just remove Defender? What if I try and defang the file? My job would be defanging the file. What are you talking about? I think maybe we should try and defang the file. I haven't done this yet, but okay, what's a signature? It's just a hash, right? I mean, that's what a lot of people think a signature is. I'm not convinced. A lot of security systems are black boxes. They just kind of operate behind the scenes. There's no real... I need a drink. Oh, sorry. Microsoft isn't going to publish how its detections work, right? So is it detecting it because it's a hash? Or is it detecting it because there's malicious behavior acting within the file? And I think really the only way to test that is to take the original LNK file, modify it, and then try and execute it, because that'll change the hash, right? That'll maybe give us a little bit more insight into how MDE works. I could just add a space. So let's go in here. Let's just download the file. All right, we're gonna download the file. I'm gonna rename it to, what'd I name this? LNK2.lnk? That's not confusing. We're gonna edit in Notepad++. Oh god, there's a bunch of nonsense in here. All right, we're not gonna do that then. We're just gonna modify the properties of the file. All right. Let's see if I can do this. So this is the part of the talk that is completely live that I haven't actually done any sort of prep on. All right, so there's all the base 64. There should be some cert-util commands in here. No, there isn't cert-util commands in here. So this is where it gets really rough. I don't know, can we just add a comment in here? Well, let me modify it. It's just making sounds. It won't let me modify the file. All right, we probably shouldn't do that then. Anybody have any ideas? I mean, it shouldn't be read-only. Yeah, but how do I modify the text file itself, or the LNK file? I can't even edit it in Notepad. It won't let me do anything. Yeah, I think we're getting into the right answer as the hex editor. But I didn't test any of this before, so I'm not going to be able to do that. All right, we're going to go back to here. So it didn't execute, but we don't really know why it didn't execute, other than MDE said it was bad. But let's pretend that maybe the next stage was. Let's pretend that this was successful. So let's look at the next stage. So we know that it is launching WScript, right? Let's go back. Actually, let's go back to this. Let's refresh ourselves. So we know that the batch file gets executed via the scheduled task, gets decoded via cert util, then PowerShell executes the JavaScript. So we can look at the JavaScript and see at what point the JavaScript, let's see what the JavaScript is doing. So again, we're in VirusTotal. This is the JavaScript. Boom, that's the JavaScript that gets pulled down. I guess before I get ahead of myself, let's look at associations. So this is really how I know. Nope, not associations, relations. Nope, not relation. Which one is it? Is it because it's all weird zoomed? Oh, it is relations. All right, I'm going to zoom back in. It just looked weird because I was zoomed in. So we know that the LNK file made the call out to that JS. So within here, we can kind of get an idea for all the different types of calls that that file makes. And from there, I'm not going to reproduce this, but from there, from VirusTotal, we can find this JS that it is actually trying to download. So when we go into this JS file, again, we see detection. Pretty much every malware provider, anti-malware provider detects it. We can go into the content of that, and we see just a whole bunch of obfuscated JavaScript. I'm going to try and remember exactly what some of this is doing. One of the main things that I'm not a Java. This is, again, let's refer back to this. We are approximately at about this point here, right, where the attack complexity is going up, my understanding is going down, but I'm still going to talk about it. So I'm not a JavaScript expert, but the best that I can do, this is heavily obfuscated. So this is actually, I'm not AI pilled almost at all, but this is actually one of the things where it's like, I can take this payload, put it into AI, and it actually does a fairly good job of trying to explain exactly what it's doing. So it's essentially launching PowerShell. It's utilizing WScript to redrop the JavaScript that was currently executed by WScript in the previous stage. It's something called a mutex, which, again, my understanding is dropping. But a mutex, it's effectively, it could be a persistence mechanism, it could be an defense evasion mechanism, but it is just taking the exact JavaScript that's running, dropping it into a new file, which what we see here in agent.js, and then it is effectively, at the end of the day, running a new IEX to invoke two different PowerShell scripts. For the purposes of this, we're just going to focus on agent 3. So this JavaScript triggered by WScript is now triggering a PowerShell script. Do we have any detection engineering opportunities? We're already at the end of stage 2 here. Should WScript, look at the entire attack chain here. Should an LNK launch CMD that launches WScript launch PowerShell to do a remote call? This is all messed up. No, thumbs down. No, this is not how you patch your computer. So let's move on to the... So let's look at this other PS1 file, right? That's a PowerShell script. It is doing an IWR basic parsing. It's downloading this helper.exe. Again, this gets like way above my head. We're now way above my head about what is actually going on here. The best I could determine is it's allocating a set of memory, like an actual block of memory. It is loading that executable. It's never touching disk. It's loading it directly into that allocated set of memory. And then it's executing that PowerShell along with a bunch of additionally, so that I think this is the part where it's actually allocating blocks of memory, but it's pretty much, it never touches disk. This is defense evasion. This is a mechanism to get the PS1, or the executable that the PS1 is loading, to really never hit disk, which MDE is really, really good at detecting malware on disk. It's kind of bad at detecting it when it doesn't hit disk. A lot. This is a real thing. Oh, yeah, no, no, I get you, non-malicious? Never. Fucking never. Yeah, so we have multiple detection engineering opportunities on detection engineering opportunities here. If we take it all the way back, so this is the whole second stage, right? Past the JavaScript. We have the execution. It, like I said, it drops mutexes. I'm only vaguely familiar with what the fuck a mutex is. It's a registry key. What's up? Agent, so, oh, it should be agent 2. You're right. It just says agent.js. Thank you for pointing out a typo. Yeah, this was the part that I spent the most effort on. So the JS executes the agent.js. It does that mutex, which then downloads agent 1 and agent 3.ps1. We only really looked at agent 3 because the other agent 1, I couldn't understand what the fuck it was doing, just to be honest, which then drops that helper.exe, otherwise known as green.exe. I don't know why it's named that. It's what the threat actors did. Ask them. It sounds friendly. And it dropped it into memory and executed that binary, which, as we find out, is the attack chain leading up to Azrael malware. So, to summarize the entire talk, there's this idea in threat intelligence, where threat intelligence should be kind of the guiding light of your security program. In order to be able to defend against what is important to your organization, you need to be able to identify what malware chain, what malware strains, what threat actors might be important to your organization. In that like analysis portion of threat intelligence, you may determine that Azrael malware is important to your organization. Within all that threat intelligence data, you're going to find, if you say Azrael is important to my organization because of X, because threat intelligence says it is, you're going to find that hash file for that LNK. If you find that hash file for that LNK, you kind of have two different paths you can go down. You can add that hash file to MDE and call it a day. But what we demonstrated was our initial access vector into the persistence mechanism, into really the first whole stage of this attack vector is not detected by MDE. So all the threat actor really needs to do is change that file, and MDE is going to miss it. So we know this hash, you can't just add hashes to your MDE or whatever, your security tools, and say we're protected against Azrael. Really, you need to go the next step and perform a function of security validation, which is testing as far as you can, even just as far as we went today when I fell flat on my face with trying to modify the LNK file. We were in it together though, so you guys failed too, really, if you think about it. That will get your security organization just one step ahead. And, screw protecting corporate interests and security. I mean, granted, that's all we work for. It's also just really, really interesting stuff. So even if you don't necessarily work for an organization that this is super applicable to you today, I kind of implore you to take this mentality and this methodology just to home in your own lab, and where it costs next to nothing to actually spin up a VM and play around and find this attack path and figure out what your security tools can and can't detect. Find those, let me go back to it. Find those detection engineering opportunities and deploy them to your organization. Thank you. That's it. Nobody look at me.
Take questions. Do you have questions?
Does anybody have any questions?
We have a question over here.
Yes, and that was the entire point. So the question was, the question was, effectively you could take that, like the first portion of that attack chain, and just do a hello world on it, right? The important part of the demonstration was not the maliciousness of the activity. It wasn't that we did anything malicious. Like nothing that we did in MDE or in my little sandbox was malicious. It's the fact that it's the attack path. It's the chain of events that leads to the malicious behavior that can give your detection engineering a uplift on getting ahead. It's proactive rather than reactive. That's the whole point. So, MDE and MDR. So MDE is Microsoft Defender for Endpoint, which is a product that's provided by Microsoft. That's like their premium tier. MDR is managed detection and response, which may leverage MDE. It may leverage CrowdStrike. It may leverage SentinelOne. It could leverage anybody, right? It's just a team of people that aren't you that is maybe looking at this stuff and hopefully doing security validation on their own. They aren't. Hopefully doing detection engineering on their own to find this type of stuff. They're supposed to be like the next level of SecOps folks. They aren't doing this. Any other questions? Good question. So, yeah, that is a good question because it all comes down to the resources. Oh, yeah, sorry. So where do you draw the line between looking for malicious patterns and obvious malicious, say, yeah, okay. So the balance is between just normal administrative activity and actual malicious activity. Is that kind of, yeah. So that is detection engineering in a nutshell, is being able to draw that line. It is difficult. It's not easy. At the same time, I'm not a detection engineer myself, but I work really, really closely with them every single day. Let's take like normal domain admin. Let's say an account gets added to a domain admin group. Let's take this as an example. Is that suspicious behavior in and of itself? Is that malicious behavior in and of itself? No. Adding an account to the domain admins group is not malicious behavior. That could just be somebody got onboarded and is becoming a DA. But do you want to notify your SOC of that activity because it's anomalous and because it's high impact? The answer is also yes. So your SOC will have to deal with false positives. But when they're that important, it's kind of their job. And sorry for all you SOC people that are rolling your eyes at me, but sorry, that's kind of part of your job when we're dealing with actual security stuff where it's, no, generally an LNK shouldn't launch CMD, which shouldn't interact with cert util, which shouldn't drop a batch file. But could it happen? Yeah. And would you rather be notified of that, or would you rather not? I'm really, I have kind of a bad picture on this because I work for Mandiant, which is supposed to be the best of the best, and we're supposed to do super, super security forward things. So my perspective is, yeah, of course we should alert on it, and of course we should just do our jobs and, take those false positives to the chest. But other organizations don't have those resources, so that is a real, actual concern. And I don't really have a good answer for you if you don't work for a multinational, big, giant company that has 11 people behind you to do all this work. I don't have a good answer for you other than good luck with the Azrael malware. Yeah, what's up? What hypervisor do I use to fire malware? I hate VMware Workstation. I'm a VirtualBox Chad in and out. I love VirtualBox. I also use Virsh, like if you're running it in Linux. There's a whole stack. At home I use Unraid. So different things for different purposes. I'm a huge Unraid fan for like home prod. For home prod, I'm a big... Sorry if you didn't get that reference, you haven't come to enough SecDSM talks, obviously. I would say VirtualBox if I'm doing it in a lab. If I like what I'm doing right here, VirtualBox all day. Nothing else? All right. Come find me if you were too afraid to ask the question out loud.